Right, so part B of this question. The line PQR shows the plan of an underground mine shaft. The entrance to the mine shaft is located at P at an altitude of 35 metres, and the shaft slopes downwards into the ground at an angle of 10 degrees to the horizontal plane. A section of the mine shaft near Q has collapsed, leaving a group of miners trapped underground. It is proposed to drill a vertical borehole somewhere between points Q and R in order to rescue the miners. Determine in plan the position of the mine shaft that will require the shortest possible vertical borehole. So it says P is an altitude of 35 metres and the shaft slopes downwards to the ground at an angle of 10 degrees to the horizontal plane. So that will be the XY line in elevation. So construct an auxiliary elevation of the mine shaft to start. So you're going to draw an X1, Y1 line parallel to that line there, PR. So you can label that X1, Y1. Alright. And then you're going to draw in your slope of 10 degrees. So I bring a line up perpendicular. And I'd measure up 35 from the X1, Y1 line, because that's the height the borehole is at. Right, so what you're doing here is getting an elevation, a look in an elevation at this borehole. So it's at 10 degrees, the borehole. And it's drilled in a point Q. So you're going to bring up point Q, get your protractor, put on that line where point Q comes up and hits that 35 altitude line. So that's an altitude of 35. Mark off 10 degrees. And draw a line down. So that's your borehole. That should come down to O. Alright. Then you're going to measure off 5mm intervals to get your elevation. It's because we're dealing with 5 meter vertical contours here. So you can label them 40, I'll go over here actually, 35, 40, 45, 50, 55, 60, 65. And you're going to bring all your contour lines. So I hope you can see that alright there. Maybe I'll just heavy those in blue just so you can see them. points up. Right, so point P is an altitude there of 35. And then where the contour lines cross over each point. So where the 40 contour crosses over there, you're going to bring it up till it hits the 40 line. 45. 50. 55. 60. 65. 55. 50. Another 50. 55. 60. And 65 at all. So that's what this hill looks like in elevation. I'll try and heavy that in a bit more. Okay, so that's what it looks like in elevation. So determine the shortest distance between the mine shaft and the surface and elevation between Q and R. This can be located in the plan. So you're trying to find, these miners are trapped somewhere between Q and R. So we need the shortest possible drilling distance to get to them. So what you're going to do is draw a line parallel to this line. So you're going to bring it up till it hits the lowest part of the hill. Which is there. So somewhere around there. And then you can bring that back down. Make sure you bring it back down perpendicular to the PR line in plan. So that gives you the shortest possible distance. So there, if you're looking in plan, that's where it needs to be drilled to get these miners out with the shortest possible drilling distance. So that's actually a fairly easy part of the question, guys. So I hope you have no trouble with that. Alright.